Hey folks, how you doing today? We're going to talk about Chapter 13, Inheritance. So I've got a quick project set up here. And we're not going to go super deep on the topic because we will pick it up again next semester in 2001. Just sort of setting the stage for some of the basics, what it is and how do we use it, and then that should suffice. And then we'll have a second video about what the final project is going to be a little bit later. Right, so the first thing, we've actually used inheritance before. We just didn't really notice it too much when we were doing unit tests, but let's do a better example here. So I'm going to write a class for, we'll say, item. And this class for item is going to have things that we're going to sell. So we're going to have an init method that takes, I don't know, how about a name and maybe a price. If not, we'll default it. No, we'll take a price too. So then we'll have self.name is the name, and self.price is the price. And again, trying to use this underscore to say, hey, these are private variables, don't be messing with these things here. So we'll have that, and then we'll have maybe, let's say this is just a regular item here. And sure, so maybe we'll use this lots of different places in our code. Maybe we'll have a get name turns self.name, and then a get price. Get price. Again, just a good habit here. So if we want people to be able to get these values out, we should give them a public method to do it here. So price. Cool. So that we can have a bunch of items, right? This will be the stuff that I have in stock, whatever it is, my sales program here that we're going to use. And I can have a list of items. I can get their names, I can get their prices, but I don't want people to change them once they're set. Maybe we do want an option here for set price, right? That has a self, and we probably should give it a price, and we'll take self price equal price, self.price, sorry. And maybe we do want to do a little sanity check here. Maybe we want to check. Let's say if price is greater than 0, let's do this thing. And if not greater than 0, let's raise a value error. Price cannot be 0 or less, right? We can't just give things away. Sure. So that's all fine. And now instead of setting self price here, right, what I want to do is I want to call self.setPrice, and I give it the price. Right? Don't do the same work twice. So use the function here to set it, and things should work out. Oh, it doesn't like that it's defined outside of the init method. That's fine. That's fine. Because we're calling it in init, so it's getting set inside of init. So it should be okay. All right, so that's price, or that's item. And now, what if we wanted to have sales tax on items? Well, if I'm using this class lots of places, I don't want to have to go add more items, right? More variables to it, change some of these things and deal with all of that. That can be a little bit of a pain. So what we have is this idea of inheritance. We're going to say, I want to make a specialized version of item. I want to do all the things item does. I am an item, but I'm a special type of item. So we're going to say this is a class for taxable item. And then in parentheses, we put item. So this says I'm going to inherit item. I am an item. So taxable item now gets all of the things that item has by default. It gets them because it is an item. And then what we get to do is we get to specialize the class and add new features. So, we'll just leave it blank for right now. There's nothing additional special to it. But now I can make items, right? I can say, hey, I want some chips equals an item. Yeah, we'll call this chips, and maybe it costs $1.50. Right? And then maybe we'll have, we need something in here, sorry. Let's see, what else do we want to do in here? We just add fast for now to make it happy. It's unhappy with that. All right, that's fine, that's fine. So let's keep going in here. So let's define our init method. Sure, we'll just have a blank init and pass. Maybe we can get away with that. Oh, that's right. Pass is not a comment. Oh man, pass. We'll just pass. All right, and then maybe I'll say, what is something that's taxable? Maybe we'll have, wow, I'm losing it right now. Food's not taxable usually, right? But some prepared foods is, but other items are not. I don't know. We'll say we want to buy here. Soap equals a taxable item. And now there's no init method here, but you'll see I'm already getting an option for a constructor with name and price. Soap and $2 for the soap. Because taxable item is an item. So if I don't have an init method, I'm using the items init method here, which is really cool. We are an item. And then soap has all the methods: set price, get name. right? The same as chips, because we've inherited all of those functions from the item class, and it's even telling you, right, that they come from item. This little helper text here. But now what's special about taxable item is that I need additional information. So I need this init method here. I need a name, I need a price, and then I need a tax rate. Right? Now what I want to do is I want to take name and price, and I want to hand that to my parent class, the init here. So the inheritance relationship, you might hear it called a superclass and subclass. So item is the superclass, taxable item is the subclass. You might hear it called the base class and the derived class. Item is the base class, taxable item is derived from item. Right? It is a type of item, it's derived. Or you might hear parent and child, where item is the parent class and taxable item is the subclass, or child class, sorry. Or you might even hear superclass and subclass, base class, derived class, parent class, child class. We use them all interchangeably. One nice way, we actually have some built-in language around superclass and subclass. So I do prefer super and sub, but I'm going to be confused and mix up and call all the different ones all the different times. So don't worry too much about it. So what we can do is I need to hand name and price to my parent class init, because I don't want to reinvent the wheel, right? I need to call this init method to make sure those get values. I'm going to say super, parentheses, dot init, and I'm going to hand it name and price. So that's one syntax. The book will also show you can say item dot under init. But if you use item dot under init, you need to give it self and then name and price. So I don't prefer this option, right? I'm not a fan of this one. And of this, because you have to use self. Just for that exact reason, right? That's it. That's the only reason I'm not a fan, because you have to remember to add self in this case, where with super init, it knows it's acting on itself, and I don't have to pass self. Okay, so again, I prefer the syntax, but you can see either. They're both perfectly fine, just one way or the other. Once we've done that, then I can do something with my tax rate. So I probably want a method here for set tax rate. Tax rate takes tax rate, and here's where I want to do that work. So I'm going to call self.set tax rate, given the tax rate. And now what I want to be careful of is sometimes when you ask people for a rate, they'll say 6%. And they'll give you 6 as a whole number. And that's not actually a percentage. The 6 is 600%, and that's probably not the tax rate. So what we want to do is we want to check and see, hey, if they gave me a number bigger than 1, it's probably a percent. Right? If they gave me 0.06, which is actually a 6% rate, then great, I'm all set. So I'm going to check if tax rate is greater than or equal to 1, I'm going to set self.tax rate equal to the tax rate divided by 100. Right? Because if they gave me 1 or more, it's 1%, 2%, 3%, yada, 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 divided by 100. If it's not greater than or equal to 1, else I can take the tax rate. Actually, I probably want to check, right? Else if the tax rate is greater than 0 at that point, then it's good. So if I know if it's not 1 or greater, but it's more than 0, it's probably a fine tax rate, so I'll take it. Equals the tax rate. If it's not greater than 0, else I'm going to raise that exception, raise a value error, and say tax rate cannot be 0 or less. Right? Same idea here. Can't do that. So now when I try and create a taxable item, I'm going to run into trouble here because I need name, price, and tax rate. And if I just give it soap and $2, again, right? Oops, 2, it's going to be unhappy with me. Let's give this a quick run. Now it says, price cannot be 0 or less. Oh dear, where did I do that? Oh, price is greater than 0, and then raise. That should be else, right? Else raise a value error. And really, I probably should be inverting this. I should say, hey, if price is less than or equal to 0, raise the value error, just to make this a little cleaner, right? You want to avoid the indentation if you can help it. Right, so I don't need the else, because if I raise an error, I'm done. Game over, right? So if it's less than or equal to 0, raise the value error. Then, if we haven't raised the error, we're fine. Again, just a better practice there for making sure those are clean. With this, we already have a bunch of branches, so I'm not too concerned about that, because we have to have an if-else anyway for the other checks. Let's give that a run. Right, now it's saying, hey, I'm missing a required positional argument. I need the tax rate, so 0.06. Okay, great. It worked. I mean, we didn't actually do anything with it yet, so that's fine. But But now what happens when we get price, it's giving the original price. What if I actually want the price to include the tax, right? So if I like get price here, if I print chips.getPrice, oops, get price, and oh, let's do both, right? We'll do a nice little formatted string. We'll say the chips.getName, cost, a $, and chips.getPrice. Okay, how's that? And the quote, single quote, and the parentheses. Okay, great. Chips, and then we'll do the same with soap. Get price and get price, right? So $1.50, $2, but what I really want to have happen is I want the tax applied. So what I can do as I'm a custom or a specialized version of my parent class is I can override the parent class behavior. So I can make my own method that looks the same. So I can have a get price, and that's going to return self.price, get price, times, and actually I don't want the self price here. I want my super, think parentheses there, get price, times self.tax rate. And that's really, in addition to plus, I don't know, or really add 1 to that, right? There. So if the tax rate is 0.06, add 1, so 1.06 times my actual get price. Now I could just go get that private value. It's still technically bad form to go mess with private values in your parent class. So not too worried about it here. So now I get the proper get price 2.12. So it'll do the correct version here, the overridden version in my child class. I'm getting the super class. So if I forgot to do this, if I just did self.getPrice, I'm going to get a big issue here. Right? Oh, I get Stack Overflow, maximum recursion depth, because get price would be this get price, which is going to get this price, and this price. So I really want that to be the super classes get price here. Again, we can use item, right? Item dot get price, and then I have to hand it self, and that's just awkward. So that is another option there. I'm just not a fan of going about it this route. So this is the item class calling get price, and you hand it explicitly myself here. I prefer the super syntax, so that's okay too. I'll just leave that one commented out. And then we'll put this one back in. Just prefer super myself. Okay. Cool. So we can override that specific behavior. So that inheritance, again, is a relationship. A taxable item is an item. And if you want to get crazy, we can have it inherit from taxable item. Right? We can have a child of taxable item that has a superclass of taxable item and a superclass of item. You can create this chain of inheritance. Right? You guys ever wonder why we could, just print soap? Like, do we actually get a string back out? Everything inherits from object. So object is actually a class in Python that everything explicitly inherits from, and it has a definition for how you turn something into string. Not a very good definition, right? This is junk, but we've got it. So everything has explicitly derived from object, which is pretty cool. And you can have multiple inheritance. You can have a whole chain of things here, and you can inherit from more than one class as well. You just comma separate them. Another class here. That gets really awkward and confusing, and I would strongly recommend against it. It's typically not considered good object-oriented form unless that class is this thing like considered abstract. Again, we'll get to that next semester. So just it's bad form, and we'll try to avoid it here. The book does talk about this idea of mix-ins, where it says, hey, I will do this method, and then we'll define what that method does, and that's one of those slightly more advanced topics that we'll get to next semester. So that's about it for inheritance. I think we covered all the things we needed to, right? Derived, accessing the attributes, overriding has a multiple inheritance. Yep, and then some tests. So unit testing is actually done with inheritance. Right? When we create tests here, which is really cool. I'll say go to test, create new tests, sure. You'll see, hey, it is class test item derives from test case. It is a test case. We just sort of, it was magic to us before, so that was fine. Okay, so let me actually delete that. I don't need it. Cool. All right, so that's inheritance. I'll have another video for you up later on the final project, and we can go from there. I can't believe we're already getting a month away from the end of the semester. Apologize for the delay on getting the projects graded. Life has been a little nuts here. I'm still out in Philly. Daughter had her second surgery. but they couldn't actually do all the things they wanted to do. So it sounds like we're going to be back come January or February. So it's going to be a long road, but appreciate your flexibility. Please reach out if you have questions. Find me on Discord. Ask me questions. Let me know how I can help. And I have been asked to let you know that registration is open, so you guys can register for next semester as well. So keep that in mind. Happy to help you out with whatever you need. Just keep in touch, and you guys take care.